If you have not been watching the latest videos on the series, what I'm making here is a chat application which I began from scratch. So it's basically using Ruby for the backend and some JavaScript with Vue.js in the front end. If you don't know about Vue.js, it doesn't matter. It's just a little bit, and it's easy to use. So probably you can get it if you want. Anyway, I'm creating this chat application, and in the last video what I did was I did a login system. So if I open an anonymous tab here and I want to perform a login, so I have the username and password already filled. Let me change that. Let me go back to where Alice is. So Alice, yeah, so I want to change these default values. Cool. So let me reopen this anonymous tab. And it's gonna have, this very basic login screen. My focus here is not to deal with CSS and styling this thing. So yeah, it's a little bit ugly, but anyway, its function it works. So if I go on with Alice and the password is secret and I log in, then I'm logged in and it works. So yeah, I have to definitely fix this thing here is broken because of CSS. Anyway, what I want to focus on this video is that this is our database of users. So here are the users. The users are kind of static, and the database is in code. In the code, the database is not on a proper database system. But that doesn't matter for now, because I plan to migrate that later to a proper database. But for now, there's a bigger problem here. And I don't want to migrate to a proper database system without first fixing this problem. So there are two security problems here. Two security problems. So these are the two users that the system has. This is the user John, and here is the user Alice. Now the way it works is, let me close this anonymous tab and let's oh, come on, localhost. I cannot type localhost anymore. Cool. So if I open the inspector to see two things I want to see here, I want to first see the network requests that are being performed. And so if I go on with Alice and I'm going to type any password here that is invalid for Alice, and if I log in, well, login failed, okay. If I inspect the request that was performed from the front end to the back end, it's going to the perform login endpoint, and it's sending down here in the request payload. So it's sending a password and username like in plain text, and that's cool. That's normal. We don't have to worry about that in a production system, because in a production system you want to be using a secure channel like HTTPS. You never want to use like this in a production system, because then everything is going through the wire without being encrypted. So an eavesdropper could just see what's been going through the wire. Anyway, so this is a common practice to just send a plain password to the server. This is not a problem. But there are other issues there. So it's sending the password, and now it's responding with, let's see the response. So yeah, just some API here, let's say, that's saying that, okay, the username and password is wrong. And well, when it actually works, so let me log in with the correct password. What happens is that it's going to perform the login, and okay, so it's the same thing, of course, the same request body, and the status is login success. And then it also includes in the response this token. So here's a token. And what this means is that in the next request, so for instance, there are a lot of requests happening here, as you see, because these requests are fetching the messages from the server. It's constantly asking the server, do you have more messages for me? Do you have more messages for me? And along, well, actually these endpoints here are not secured yet, but there's one endpoint that is secured, which is the one, this one. If I want to send a message, send, and I'm going to actually go ahead and do that. Send a message. So I'm going to send a chat message. I click send, and here is the thing. So it went to send message endpoint, and in the request payload, it contained the message itself, so what we type in the message field, and also it added this header here, so API token, and this token is what was retrieved when the user logged in. So the user logged in the login endpoint, and the login endpoint said, okay, login is successful, here is the token. And then the next requests are the password is never gonna go again in the next request. The password is only sent once to authenticate, and is kind of going to exchange the username and the password for a API token. So this API token is then returned. It's stored here in local storage. If you want to know more details about that, go and watch the previous video. And yeah, so you're using this API token now to perform requests. This is a common practice. I mean, using this header name is not a common practice. This is not a good thing. Usually would want to use a header called authorization, or you could also put in a cookie. So putting the token itself in a cookie is also very common in web development. So yeah, here we have this token, and the thing is that well, the first problem here on our database is that the password is here in plain text. So we never want to store passwords in the database. Never, ever. You don't store a password in the database. That's the way you do security. You don't store passwords in database. Also, the token is also stored in the database. So it's also stored in plain text. So this is also a problem because the token is essentially a password. So if an attacker or a hacker or something like that, if this person gets access to the database, they can leak the database somehow. Well, they can get the usernames and passwords, and they can go on and log into the system. And even if the password would be encrypted or something in the database, they could still if the token was there just in plain text, they could also perform actions because they would just call the API endpoints using the token itself. So what you want to do is you don't want to store the password, and you don't want to store the token. So one approach to do that is but for sure we gotta have still a way to know, well, when a user performs a login, we want to know if they type the right password in. And when the same thing for when doing API calls, we want to know if the token is correct, it matches the token. So one way that one would think that would work to do this is to actually go ahead and encrypt the password and encrypt the token and store these things encrypted in the database. This is also not a good practice, so you should not do that, because if you have the encrypted on the database, you can revert it, so you can decrypt it and get back to the original password or to the original token. And if the hacker gets access to the database with the encrypted passwords, they probably also can get access to whatever your key. So if you're encrypted, you need an encryption key, and it's very likely that the hacker is also going to be able to get to that encryption key. So they will be able to get the original password and token nevertheless. So what we actually want to do is we want to store a hash. So if you go hash function. So if you don't know about hash function, so we're going to use a hash function. So a hash function is just it's gonna kind of encrypt. So it works like encryption. So it takes your data and it mangles it in a way that you cannot read it anymore. However, there is no way to decrypt it. There is no way to go back to the original. It's impossible because hash algorithms are designed to do that. And yeah, so I'm going to do that. I'm going to work on that on this video. So enough talking, and let's start programming. And Ruby has for Ruby you can use this. Ruby has this bcrypt gem. Ruby, yeah, bcrypt is kind of an algorithm, or it is actually an algorithm. And there's a gem called, so if we go to Ruby gems, and I use this bcrypt thing. So yeah, so I want that. Therefore, I'm gonna put in my gem file. And in fact, I already did it. So I add this gem bcrypt here, and then run bundle install. And as I said, I already did it. So bundle or bundle install, they're the same thing. And now I want to store the password using this thing. So if I open bundle exec IRB, the way it works, well, actually, let's do it right ahead on code. Well, no, we need, I'm gonna need this. So bundle exec IRB, require bcrypt. And the way it works is that you make a password. So password, let's say pwd, password equals bcrypt. I think it's like this. Password.create, and it's not new, it's create. And then we want a password. So the password for John is going to be secret. And I'm going to store it. This string here is going to be the password. So now this is the password. And for Alice, the password is also going to be secret. So it's the same password. However, I'm going to generate it again. And well, you can see here that although the passwords are the same, they are stored differently in the database. So, this gem is really good because you don't have to worry about a lot of stuff. I'm gonna use single quotes here. Oh no, yeah, there's no problem using double quotes. Yeah, this gem is just awesome because you don't have to worry about I don't know, like security details. You just use it like this. So it has this. It has way more functions, but it has also this bcrypt password thing, which is just easy to work with, and you don't have to worry. So you see, the password is the same for both, but actually the content here, the encrypted password, is different. And yeah, I'm not gonna through that. I'm just gonna use it like this. And then we have to change, if I restart now the server, if I restart the server, I cannot log in anymore. So I'm gonna log out, I'm gonna open an anonymous tab just because then I don't have the, yeah, I have another anonymous tab. I should close it before. So, okay, now I have to log in. And I'm never gonna be able to log in. I mean, if I put here Alice and secret, which is supposed to be the valid password, it is gonna fail. And of course, if I just copy paste this, like this thing here, of course I'm gonna be able to log in because it's just comparing a string, but that's not the way it should be. So we have to change the code that checks the password. And to do that, the first thing is to require the bcrypt gem, because we're gonna use it here. And then we go to the endpoint that performs the login. So here I put this comment here, authentication stuff, which is to separate the code. So anything below this line is gonna be authentication stuff. So post perform login is called whenever the user clicks the this login button, then it comes to this perform login thing. Let me do, yeah. And it's gonna load the payload, which comes in the body. And it's just gonna go through all usernames and try to match like the username with the password. So I wanna change that. To well, it's gonna be well, I'm gonna do it like this. So authenticated, or yeah, matched user equals, and then I'm gonna say nil. And then if user username matches, then I'm gonna say that this user is this one. Or maybe I could, well, in Ruby, I can do it differently. So I can go and say match user equals, and then I can do this and find, and I can remove this if. So whenever this is true, this is going to return this thing over here. So matched user, and if it doesn't find anything, it's just going to return nil. So it can be that this is nil when the user does not exist. And then we can say something like if match user, so if it's not nil, then we want to compare the password now. But the password comparison is not going to be like this. So user password equals, and then bcrypt password, and this time it's going to be new instead of create, and we want the user password over here, and then we want to do like user password equals whatever is in the came in the payload. So if this is true, then we return that the login was successful. So let me check this again. So yeah, this is gonna recreate the password instance from the whatever is in the database, and I'm gonna call it user password, and if user password equals to whatever came here. So this is comparing, actually this is comparing instance of password to a string, and this is gonna return true whether the password matches, otherwise it's gonna return false. So let's go ahead. There's still a security issue here, and I'm gonna fix that as well. But first, let's just go over here and refresh this. And if I type in just anything, so let's do some testing. Wrong. Okay, so let's go with Alice and then a wrong password, because now this is gonna enter this if. So I want to check if this if is able to fail. And well, I think probably some error happened. Yeah. Undefined local variable user. Yeah, because I forgot to change this to match the user. So actually what I want to do is I want to do it like this. I'm going to use this here not to clash variable names. If user, and then user, and then user. Cool. So restart the whole thing. So if user, and then I go and Alice, and then whatever, log in, well, failed. And if I type in the correct password and click login, so now it works. So yeah, there's another problem here, which is, well, it works, yeah. And let me log out. I log out by going to application, local storage, and cleaning this local storage thing. So I want to delete both these values, and if I refresh, I'm logged out. So yeah, there's a problem here. Let's see on network. So Alice and then whatever. So this request took 200 milliseconds. This one took 198, and this one, so average 200 milliseconds. Now if I go with something else, you see that it's much faster. So this one took the difference between these ones is that here I had just an invalid username, a username that is not in the database, and this one's is a username that, sorry, this one is a user that is in the database, and this one is a user that is not in the database. So John, for instance, John is a valid user, it's on the database. And if you look at it, it takes 200 milliseconds also in average. And if I change it, then it's again like very much more quickly. So this is a problem. Why? Because I can identify just by looking. So it's possible that a hacker could identify whether a user exists or not on the database just by looking at the timing, just by looking at this. So I know that when the time is like about 200 something, although the password is invalid, I know that the user is there on the password. And then it makes it easier for the attacker, that they just then have to figure out the password. Or maybe they're not trying to figure out the password. Maybe they're just trying to figure out if the user is on the database. So if you pay attention to some software systems, when you go and you log in, and it's usually you log in with your email address and password, and then you type in the. So if you go to forget password, there's usually software in web software, they usually have this forget password thing. And if you go there and type in your email address to recover your password, it's quite common for software to have this feature that they won't tell you whether your email address is valid or not. They will just say, well, if this email address is belongs to a user in our database, then we are gonna send you an email. So you don't even know. So if you have like 5 different email addresses and you don't even remember which one you used to register in a certain system, this system is not gonna tell you whether that email address is registered on their system or not. This is just a security thing, that they don't want the attackers to get information from the database. They don't want the attackers to be able to know if a given email address is there or not. So this is similar here, and this is called timing attack. So if you go to, I'd say that a reference is OWASP. WASP is a good website to timing based attacks. So if you read about it, timing attack, Wikipedia is also fine. I'm not going to read this, but it's exactly what is happening here, is that just by looking at the timing of something, you can infer some information. In this case, the information that the attacker can infer is whether the user is registered in the system, which is these cases here and here, and whether the user is not. So which are these very quick requests. So we want to fix that. And to fix that, we could just, the ideal goal is that every request would take a constant amount of time, that the attacker wouldn't be able to figure out if they wouldn't be able to figure out anything. So why is this happening in the first place? So why 200 milliseconds? That's because this comparison here is slow. So this is slow, this is not fast. And if the user is not found in the database, we are not performing this comparison over here. So that is basically the thing. That's the reason for this. I think that the bcrypt password already has some scheme inside to mitigate timing attacks. I think that. I don't know. I haven't studied that library in depth like that, but I would suppose it has. So that's why it also is slow, because 200 milliseconds is quite slow. So the way I want to fix this is that I want to do this comparison, even if the user is not there. So to do that, I'm gonna do like this. So if user password is or I can like put an else here and do something like I don't know, something foo equals bar. Actually, this is not gonna work. It will have to be create instead of new. And let's see how this goes. So essentially, this is doing nothing. This is just wasting time, and that's the goal here, because this is a timing attack. So we wanna affect how the time of the request is gonna work. So let me put like that, John, and then anything invalid. And well, again and again. So yeah, still about 200 milliseconds. And if I put for a user that does not exist, well, now that's that didn't fix the issue, that just changed the issue. But now it's like 400 milliseconds. And I think the reason for that is because this is taking quite some time, this crate, and then the comparison is taking another amount of time. So what I want to do is I don't want to do this crate thing over here. I want to just do this new, and I want to take any password, like a dummy password. And I'm gonna even go ahead and generate cd. I want to just generate any password. bcrypt password dot create. So it's gonna create a new password. Hello world. Oh, that's hello world. Anyway, wouldn't change anything. I'm missing that G. So I'm gonna do this, and it's just gonna compare to whatever the user has typed in. Let's say, where is this? The payload password. And then I can also, let's just put it like this. So restart the server. And well, let's see again. Let's see now how it works. So 200 milliseconds for invalid user. So this flow here is entering this else because the user is not being found. So this is now taking about 200 milliseconds. And Alice, which is a valid user, is now taking about the same amount. So there you go. I wouldn't say that we fixed this because it's hard to say. I mean, it's just average values, but essentially you can see that now it's at least much harder for somebody to. I mean, how can you differentiate between this thing? If I would just, I don't know, like shuffle these values in a random order and would present it to you and tell me and say like, tell me the difference between. Can you put this into groups, like in a group that has a certain timing and a different group that has a different timing? I think you would not be able to do that. So I think we solved it. In practical terms, we solved it. So now we don't have timing attack problems anymore. Cool. So now we learned also that this comparison here can take like 200 milliseconds. And this is not, I think this is on purpose. And the reason for that is this is not just because my computer is slow, because it's not. And it's also not because Ruby is slow, because although Ruby can be quite slow, this bcrypt library, it's not implemented in Ruby itself. So the heavy lifting of it is implemented in C. If you go to bcrypt, you're gonna see that this has this lib. Well, anyway, yeah, it has this XT folder with some C source code here. So that it's quite fast, and I suppose the slowness is either, I don't know, I don't know, but it's just slow. It's just slow. I think it's maybe because of the bcrypt algorithm is slow, or because it has some protection against timing attacks already. I don't know. But anyway, it's slow. It's 200 milliseconds. And then for a login, that's fine. I mean, if your login takes 1 second, that's already fine. If you type in your username, password, click login, you have to wait for 1 second, that is fine. And especially 200 milliseconds. So that's especially fine. However, if you're doing, let me see if I can log in. Yes. So yeah, I can log in. Now imagine, look at these requests over here. They take like 300 milliseconds. 3 milliseconds. So that's quite fast. Now, if we would have to verify anything, like the token, for instance, if we would have to verify the token using this bcrypt thing, it was super slow. So our API would be super slow. And we don't want that. We don't want slow APIs. So we want quick APIs. And then if I go back to the original problem, we solved this password problem. It's solved. But however, the token problem is still there. So the token is still on plain text here, and I want to solve that. But if I just go ahead and use it like this, it's kind of not gonna solve it, because then we are going to introduce another problem, which is slowness, and we don't want slowness on API. So that is why also you don't send the username and password in every request, because username and password is going to be a slow operation, and it's good that it's slow, because then you can limit if like you're talking about an attacker doing a brute force attack, which is just trying very quickly different combinations of username and password in order to try to figure out the username and password. What is going to happen is that it's going to be slow. So if the endpoint is slow, they cannot do that many requests per second or per minute or whatever. So they're limited in that sense. So it's good that it is slow, but for the API, we don't want to make the whole API slow. And then we have a problem, because if it is, I mean, we could, like, comparing the token is fast, as you see, just 3 milliseconds. And I assure you that we can do a comparison, a better thing than this, that's just plain text, that is also going to be fast. But then you think, well, then there's the problem that it's easy for the attacker to do many requests per second, and they could maybe figure out the token. Yeah, that's true. So we can mitigate that. We can have a fast thing while also having a secure thing. And the way to do that is, if you think about tokens, they're usually like a user password. So let's talk about user password. How many times does a user change their password? Well, not so many times, right? They change, like, I don't know, once, twice a year or so, maybe. Maybe even less than that. However, the token is quite common for it to have a short expiry date, or they're not gonna last long. So maybe they last only 2 hours. Maybe they last like 24 hours. Maybe they last just 1 month. I don't know. Could be anything like that. So if the token gets leaked somehow, it's not so big of a deal, because it's going to expire soon either way. But then you have to have a mechanism to keep refreshing tokens, because if the token expire, you don't want the user to have to log in again, but you want the login to happen automatically, and then the token is going to be refreshed by the system, by the front end or whatever. And yeah, let's get hand in code so we can start doing something. And the way I thought about doing this token is that I want to use a hashing function. I don't know if bcrypt has hashing capabilities. I think it does not. So if I type in hash, yeah, no, it's only talking about password hashes. So to do a hash, Ruby already has something, which is the open SSL. So Ruby hash. And the token, yeah, I'm gonna let the token. Actually, I don't want to let the token here. So that's the first thing. I don't want to store. The token is gonna be generated automatically. And to generate random data automatically, we can have the secure random. This is, you don't have to include a gem. This is native of Ruby, so just put in there secure random, and then this token, I'm going to delete it from here. Delete also this token. And token. Yeah, so whenever we perform a login, I want to also go and generate a token for the user. So if the login is successful, then say like generate user token, and then for the user, and I want to do it like a function over here. So this is going to generate the user token for the user. Then I'm going to say that user token, or yeah, or I could say, instead of doing like this, I could do it like this, and then say token equals generate user token, and then we return that token over here. Then I say that user token equals to token ultimately. So I'm gonna let this as the last line because it's also gonna return this value, which is gonna be the token. And I'm gonna generate the token here. So token is gonna be secure random. And I'm gonna use alphanumeric, like 64 bytes. So what this does, let me actually go ahead and show it to you. So if you come over here, so B, I think I said it many times, but B is just short for bundle exec. And I have to require secure random before using it. So this is just gonna generate a random string of 64 bytes, and they're gonna be like alphanumeric characters. So there's gonna be no weird characters in there. So you could use, for instance, with bytes, and bytes would generate random bytes, but that's maybe that's not good to return in JSON. I don't know. For the sake of simplicity, let's just go with alphanumeric, which is just going to return letters and numbers. So 64. So the longer this token is, the more secure it is going to be. So let's put 128. 128 is probably good enough. So token. Well, actually, that's it. That's already done. That is already something here. And let me restart the server. And let's go to the chat. Let's go to the anonymous tab. And actually this tab is not going to work anymore. So I'm going to go to application, and I have to clean these two values. So I'm logged out. And then I'm going to log in with Alice, secret. Nah. And then now we have the token here, and you can see that the token is quite long, so that's 128 characters. Now the question is, does it work? So I know that the token is used whenever I send a message. So let's say hello security, and I committed a typo. Hello security, is this gonna work? There we go, it worked. So this request had this API token, which is now 128 characters long, and it works. However, there's a problem here, because if I restart the server, so if I restart and I send another message, it's gonna fail. So panic message could not be sent. Well, how so? That's because it's using the same token. However, since we are not storing the token anymore on the database, then, well, we're not storing the token, so how can the system know? So the problem is that the system is generating the token on demand, but it's only being stored on memory. So only memory. So you restart the server, it's a problem. So you don't want that. I don't want that. So this is actually quite secure, but it's not. It doesn't work. It doesn't work because if we restart the server, we're gonna lose the token. So how do I fix that? I fix that by actually, to fix that in a more permanent way, I'm gonna need a database. So this is a crappy database that is only on memory, and I can do some very, very simple database now. Maybe. Yeah, I think I might do it. But yeah, didn't want to make in this video, but I think I can do it. So yeah, this is already secure. But if I would like to store this in files, so let's go ahead and say like something like, well, actually, let's do a database for the users, and the database is gonna be a file. Yeah, it's gonna be a file. So I'm gonna change this to, and I'm gonna call it like users.imo or JSON, not IMO, and it's gonna be a list. So this is almost JSON, and I just wanna go, and in JSON you need double quotes everywhere. So double quotes here, double quotes here, and yeah, this is already valid JSON. So that was quite fast. Now, then here I can, instead of having it here, I can just load from that file. So file.read, and then users.json. Users.json. I wanna make a, well, I wanna put this somewhere if I lose this data. So user database is, it's just loading this file. And I wanna have also a way to save this database. So def save, come on, save users database. Yeah, let's do it like this. And what it's gonna do is that it's gonna take the users DB, and it's going to users DB is gonna go like multi-json.dump, which is gonna convert this to a JSON. So content, and then file.write, and the file name is users.json, and then you save the content there. I don't need this. And whenever we generate a token, we can now say, let's save the user database, but now we want to return the token over here. So this is something we can do. So this already works. So let me restart the server and keep a watch in this file. So if I now come over to application, local storage, and clean this, so I'm logged out once again. And now I go to refresh. So whenever the file changes, it's gonna change here my code editor. So Alice and secret didn't work. Why didn't it work? Secret didn't work. Why is it not working? So, now I'm confused. Multi-JSON load, file read, users JSON. So the users should be here. No, why is I know why. Okay. The reason is because these are strings, and in Ruby these were symbols. So I can either I want to change this so that they are symbols. So I'm gonna do a map here, and I have to transform every entry. I can do like each, and I don't have to do it like this. I can just do it like this, an entry, and then entry equals Nah, I want to do it like this. So it's going to be a list, and then each entry is a hash. And then I want to change the keys of the whole hash. So to change all the keys, I'm going to do a function to do that. I think there are some ready functions there in some gems, but I don't want to import yet another gem. So I'm going to say like symbolize keys. And then I'm going to put a function here. Well, actually I cannot do that. I have to do like this. Yeah. So I'm going to have a hash here. And I'm gonna get this hash, and I'm gonna iterate over map do, and it's gonna be like key and value, and then it's like key is gonna be choose symbol, and then the value is gonna be untouched. And to convert this back to a hash, I can do it like this. So yeah, it's not the most beautiful code, I would say, but it's code, it works. And yeah, it's gonna solve our issue. So login once again, now it worked. And I missed the file update, which is now null. So I lost my whole user database. I'm glad I saved it in my clipboard. So null, why is it null? User DB, am I using the wrong database here when saving it? Save your database, yes, I used the wrong variable name. And then it failed silently. So let me do that again. And now I have to log out here again, delete, refresh, Alice, secret, login. There you go. Yeah, the problem is that now it's ugly. And I think, oh, come on. I think there's a way to dump beautiful data, like, or should dump data pretty true. Yes, pretty true is gonna like puts this pretty false. Yeah. Anyway, this is gonna work. So I'm gonna change that. If I write here is pretty true, Great. So, well, now it's ugly, but I'm gonna log in with John in an anonymous tab now, and it's gonna get beautiful again. So John, secret, login. I forgot to restart the server. Come on. Now let me close and open this again because I want to see if that works. So John and secret. Cool. Now you see that what happens now is that the token is now stored on the database, but it's still stored as a plain text. And if I now, well, solve the problem that if I restart the database, the server, I mean, I'm still logged in. I can send messages. Hi, I'm John. This is getting pretty messy here. But there you go, it's here. Hi, I'm John, and it's also here. Hi, I'm John. So next step is to solve the problem of this token being stored in plain text. I'm going to, instead of storing it like this, I'm going to store a hash of it. So in order to calculate a hash like a SHA-256, I can use the library called OpenSSL, which comes already with Ruby. And we can see the documentation here. So what I really want is this OpenSSL digest thing here. So if I go like that, and then it's called hex digest, and I think, if I remember correctly, the first parameter is the algorithm that we want. Yeah, there you go. So this is calculating a hash of this content over here, and the algorithm is this one. So it could be MD5, could be MD4 maybe, could be SHA-1. I think it goes through SHA-384. Anyway, I think this one should be good. And yeah, the way I'm gonna use it for storing the tokens is this one. So to begin with is to, well, I keep typing things wrongly, and require OpenSSL. That's the first thing, and after we want to change the generate user token function. So here I'm generating the token like this, and And the idea is that, so I'm gonna copy this and put it here. So the idea is to generate the token. Oh, come on, secure random. So token equals this. Then we take that token and we say hashed token equals this. So it's gonna calculate a hash of the token, and as you can see, the hash it has a fixed length, so it's always gonna be this. And I think it's well, how long is this? Hashed token length 64 characters long, which means each character is a byte. So it's 32 bytes always. That's the size of it. And yeah, so we calculate this hash and like here, and then we store, instead of storing the token, we store the hash of the token. But of course, to the user, to the API, we return the token itself. But in our database, we are never going to store the bare token. So what happens now is whenever we have a API request that has to be authenticated against the API token, like here, like so the send message endpoint, it needs authentication with the API token, and we have to change this function here. So this function is finding which user is using that token. So we won't have the tokens anymore in the database. So we will only have the hashed tokens in the database, and therefore we need to calculate the token hash from the API token that the user provided, and then we have to compare to this hash. And that is basically how I solve the problem. So let me once again restart the server, but before restarting, I want to come to the database and remove these tokens from here. So remove them. And this is well, this is not valid JSON because JSON cannot have these hanging commas there. So let's remove that. Start this server. There you go. It's already making requests. And well, let's log out. So I'm going to close this, and to log out, I'm going to delete these. And yeah, so Alice, well, I'm going to use any invalid password. And I hope this file doesn't get updated. That's correct. So if I log in with the proper password and I click login, now Alice has a token. And you can see that the size of the token has reduced. That's because it's not the token itself, but rather the hash of the token. But here we have the token. Here in the front end, we have the full token, which you can see is 128 characters. And then I'm gonna send a message like, I don't know, full bar. Hit send, and it should work. So Alice full bar, and if I go to network, here's the request, the API token. So this is the full API token, and now it's being compared on the backend as a hash. So that is basically how we now have a. I want to log in with John as well, just to make sure it works. That's how we basically now have this thing working. So John password, what's John's password? Is secret. And I know that the only thing that is authenticated here in this chat is the request that post messages. So these requests are not authenticated yet. That has to be still fixed. But for now, only this send message. So let me clean this again and send a message. And I can see that it took 5 milliseconds. So that's quite fast. If we were using the same thing here, a bcrypt thing, it wouldn't be as fast. It would be at least 200 milliseconds, as we already saw it. And if I type anything else, so let's take a few more measurements. So this one took 4 milliseconds, 4, and another one. This one took 4 milliseconds as well. So that's really good. Token authentication is really fast. It's just a matter of this computation over here is really fast. And then after it, it's just it didn't change much. It's just comparing the tokens until we find it, and then proceed to the code to insert the message itself. Cool. So now the chat system is a little bit more secure, and yeah, I hope you got something. And this is it for this video. See you next time. Goodbye.